Point Nemo, often called the oceanic pole of inaccessibility, is the most remote point in the ocean, located approximately 2,688 kilometers, about 1,450 nautical miles, from the nearest landmasses. Named after Captain Nemo from Jules Verne's asterisk, 20,000 leagues. Under the sea asterisk, this isolated point lies in the South Pacific Ocean, equidistant from Ducie Island, Pitcairn Islands, Motu Nui, Easter Island, and Maher Island, near Antarctica. Its location was calculated by a Croatian-Canadian survey engineer, Hrvoje Lukatela, in 1992, using advanced geospatial software. This precise location offers a unique intersection of geography, marine science, and even space research. Point Nemo is not only remote, but also serves as one of the ocean's least biologically active regions. With no significant currents to circulate nutrients and sunlight penetration limited by its position and depth, few species thrive there. This ocean desert is so devoid of life that its levels of biological productivity are some of the lowest in the world. The distance from shore also makes it difficult for most marine animals to reach, which results in an ecosystem starkly different from the bustling biodiversity often associated with marine environments. The creatures found in this area are mainly microorganisms adapted to survive with minimal resources. Interestingly, Point Nemo is so far from human habitation that at times the closest humans to it are astronauts in the International Space Station, ISS, orbiting approximately 400 kilometers above Earth. This remarkable fact underscores the remoteness of Point Nemo, as even the spacebound ISS orbits Earth with a regular frequency, while Point Nemo remains untouched for extended periods. For maritime expeditions and researchers, the closest access point remains thousands of kilometers away, making it an area of intrigue and scientific interest for its undisturbed environment. In addition to its geographic significance, Point Nemo serves as an unofficial spacecraft cemetery. Many decommissioned satellites, rocket stages, and other spacecraft are directed to crash into the ocean near this location upon re-entry, ensuring they do not endanger human populations or infrastructure. The spacecraft cemetery concept exploits the vast uninhabited area surrounding Point Nemo, which minimizes the risk of accidental encounters. Since the 1970s, over 263 pieces of space debris, including parts of space stations, have been buried here in the depths of the Pacific Ocean. The waters around Point Nemo are also integral to studying plastic pollution and its effects on the oceanic environment. While the area itself lacks significant marine life, the presence of microplastics even in this remote location highlights the extensive reach of human pollution. Sampling efforts near Point Nemo have discovered microplastics, showing that even the most isolated points on Earth are not immune to the global pollution crisis. This is significant as it emphasizes the pervasive impact of plastic waste, calling for increased conservation efforts worldwide. In terms of navigation and oceanography, reaching Point Nemo requires advanced planning and resilience due to its distance from land and the lack of refueling or support stations nearby. Maritime vessels rarely pass through, as the region lacks commercial shipping routes or fishing zones, given its sparse biodiversity. Most of the activity that happens near Point Nemo is limited to scientific expeditions or intentional spacecraft re-entry missions, which are meticulously calculated and rare. The challenges of reaching this remote oceanic coordinate make it one of the last frontiers on the planet. The region surrounding Point Nemo is notably free from the light and noise pollution that affect so much of the Earth's oceans and skies. This makes it a valuable site for studying natural oceanic sounds and understanding the effects of sound pollution on marine ecosystems elsewhere. Scientists can observe baseline acoustic data in the region, which aids in understanding the full impact of shipping and industrial noise in more populated marine areas. The pristine auditory environment is an unexpected but vital aspect of Point Nemo's contribution to environmental research. Point Nemo is also a key location for studying ocean currents, especially the South Pacific Gyre, which circles counterclockwise around the pole. This gyre creates a relatively isolated body of water that does not interact much with other ocean currents, limiting nutrient inflow and oxygen distribution, which further affects the area's low biodiversity. oceanographers and climate scientists study this unique phenomenon to understand more about global ocean currents and their role in climate regulation, as the gyre's movements are essential in controlling water temperatures across the Pacific Ocean. The seafloor beneath Point Nemo remains relatively unexplored, and given the logistical and financial constraints, it is unlikely to be explored fully anytime soon. The ocean depth in this area reaches around 4,000 meters, 13,123 feet, making it challenging to deploy submersibles or robots. Advances in remote-operated vehicles, ROVs, and autonomous underwater vehicles, AUVs, offer potential future exploration methods. However, the seafloor's lack of biological diversity and geological interest, compared to mid-ocean ridges or hydrothermal vents, has made it a lower priority. In sum, Point Nemo represents a unique and extraordinary point on Earth where humanity's reach, influence, and presence are minimized, allowing scientists a rare look into an undisturbed, remote oceanic environment. Whether studying it as a spacecraft cemetery, a site of minimal marine activity, or an uncharted abyss of the South Pacific, Point Nemo provides insights into both the limitations and the vast reach of human impact on Earth. It remains a symbol of isolation, intriguing not only scientists and researchers, but also those fascinated by the edges of our world.